Hello, everyone. Welcome to Cincinnati Software Craftsmanship. I am excited to have you all here today. I am very much looking forward to this talk, and I hope that you are as well. So I just want to say welcome. We're glad to have you with us. We have a great presentation for you tonight. We have a couple very small items of business to go over as we get started. So first of all, just a little promotion. You want to join us on meetup.com. That's kind of our central place for coordination. You want to make sure that you follow us on LinkedIn and Twitter to get the very freshest Cincinnati Software Craftsmanship news. Also, you can subscribe to Twitch and YouTube to get all of our newest videos. I want to say thank you to Kroger Technology for sponsoring the meetup. We really appreciate that. And I also want to specifically thank the CSC organizing team. I am not able to do this by myself. There's a bunch of people behind the scenes helping out, and they deserve a ton of credit. And without them, this meetup just would not be possible. So thank you to them. I specifically want to give a call out to Randy and to Kat and Randy, who have really stepped up recently and made a huge impact. So thank you to all of them. So also a reminder to stick around after the talk. We'll be giving away a license for any one JetBrains products. That's pretty cool. We also want to tell you about our upcoming meetups. We don't want you to miss out on anything exciting that's coming up. First of all, we have on April 17th, Matt Elin will present an intro to application architecture and scalability. And here to tell you about his talk, we have the one and only Matt Elin. Welcome, Matt.
Thank you. Glad to be here.
Cool. So tell us a little about your talk and what who should attend and why.
So I've been in the software as a service industry for about 20 years, and there's a lot of concepts related to application scalability and architecture and building things as they grow. So this is a talk to really sort of condense that into high level. How do you talk about application scalability? What are the things that you need to consider as an application grows? This is sort of intended for a newer developer or somebody who's not familiar with a lot of these advanced technologies, just to see more of a breadth of what's out there and what it can do for you. So we're going to be talking about the client side, the server side, APIs, databases, as well as getting into things like microservices, containerization, and virtualization. It's a bit of a lightning tour of the whole landscape, but you're going to learn some new concepts and come out of that with some more things you want to learn and be a little bit more comfortable talking about scalability.
So that's awesome. Yeah, sometimes it's just so valuable to have that map of the territory so that you even have your bearings around what concepts are. Yeah, I think that's awesome. And I think the other thing, even for a more experienced developer, it doesn't hurt to come back to this occasionally and take a brief overview and make sure that they're refreshed on some of these concepts.
Yeah, and it's always changing too, the landscape. We're talking about some newer things as well as some older things.
Awesome. Thank you so much, Matt. I'm really looking forward to your talk. And so make sure that you all RSVP for that talk on April 7th. We'll drop that in the chat here in just a minute. So next, I want to say welcome to Matthew Groves. Can we get some applause in the chat for Matthew? Really looking forward to this talk. So, Matthew, what do you say? Let's model some data.
Oh, do we have to?
I suppose.
All right.
I mean, that's kind of why we're here.
Okay.
Without further ado, I'll give you the floor. Thank you so much.
Well, thank you very much for that intro. I appreciate that.
Have a lot of fun.
Thank you. And hey, everybody in the chat. Good to see you all here. Thank you for all those emotes and those emojis. I appreciate that. We're going to talk about some data modeling today, and specifically JSON data modeling for document databases. And I want to start by saying that I expect that many of you are familiar with modeling relational databases. Most developers are probably familiar with this if you're familiar with databases. But if you want the benefits of a non-relational database, and we'll talk about what those are, you're going to have to think differently about modeling. So I just want to say that I'm here at the Cincinnati Software Craftsmanship meetup here. And so if you're watching this video elsewhere, make sure to go and check out all the various links here, the Twitter, the LinkedIn, the meetup, and go check this out. So it's a great group. And I live in Central Ohio, but Cincinnati is one of my favorite places to go. And I usually get down there several times a year under normal circumstances. So I'm really missing like Jungle Gyms and Kings Island and Blue Ash Chili, the Banks, the Reds, of course. I'm a huge Reds fan from way back. And actually, during my time at Couchbase, I got to work on a project with the Reds that was using Couchbase. So that was a lot of fun for me to be involved with that. That was very cool. I'm Matthew Groves. I am a product marketing manager for Couchbase. That's right. I'm in marketing now. Some of you may have known me when I used to have a developer advocate was my title, but I'm a product marketing manager now, which means I work on a lot of that baloney that developers get annoyed by, but I'm trying my best to make it less annoying, more valuable, and more technical focused as much as I can. So I'm trying to work from within the system, I guess. And you can find me on Twitter and LinkedIn. I have all kinds of other stuff that I do there. But let's get on with the modeling because that's what you're here for. We're going to talk about why NoSQL in the first place. What's in it for me with NoSQL. We're going to talk about how to model JSON data. That'll be kind of the crux of the session there. And how accessing data figures into modeling as well. Because it's not just about a model on its own, but it's, we're modeling it in order to be able to read and write data. And then we'll talk about migrating data and what that means, going from, say, a relational database to a document database. And then I have a demo of something that I want to show that I think is pretty cool. I'd love to get feedback on it. So hopefully we'll have time for that demo. It shouldn't take too long. We'll get to that demo towards the end. But it involves all the things I'll be talking about today. So why NoSQL? SQL databases, relational databases are great. They give you lots of functionality. They give you a great set of abstractions. But one of the things about NoSQL that I think applies to a lot of us is that change is inevitable. And relational databases, sometimes they don't handle change as well as we'd like. And so the other thing that is another feature of this is related to change is something Matt will be talking about next month is scaling. So NoSQL databases, especially the ones that are designed to be distributed databases, they tend to help solve these problems of agility, scalability, and along with that, performance and availability, high availability as well. We're going to talk about what NoSQL is a little bit first, because NoSQL is a term I really don't like. It's all over our marketing material. It's all over our website, but it's a term that really doesn't mean very much, other than it's something that's different from the way we've modeled data since the late 70s. So there's a whole bunch of different NoSQL databases out there. I'm going to focus mainly on document, and you can think of document as like a special case of key value. And there's also graph and wide column. I'm not going to talk about those so much today. Yes, Cosmos is everywhere because Cosmos is a multi-model database that you can configure to be any one of these types of databases as well. But a document database is basically like a key value database. So think of it as a giant dictionary, essentially, except that the value of those key value stores is in a special format, usually JSON. But this is why it's called NoSQL to begin with anyway. Way back in the day, it was something you would just have these GET operations. You look data up by key, you look at JSON up by key, you set it by key, replace by key, etc. And you might have something like a map reduce along the way to help you reason about data without knowing the key ahead of time. None of these involved writing SQL, and that's kind of why it was called NoSQL from the very beginning. Now, a lot has changed since those days, and so the NoSQL word is even less meaningful than it was before. So I like to at least drill down to say document or key value or something like that. But think of the document database as a simple type of a key value store where the values in known format. You write code where you start with a key and you ask the database to return that document for you. And the same goes with creating and reading and writing. If you're using, so scalability is one of the issues, one of the main reasons for NoSQL to exist. And so even if you're using a cloud-based database, this is what's going on behind the scenes, right? So we have what's called a cluster. We have multiple servers. I refer to them as nodes, but multiple servers that all join together in a cluster. And as we need more capacity, we can keep adding more nodes to this cluster along the way. Now, to a developer's point of view, hopefully this cluster will look like one thing, but behind the scenes, it's actually a bunch of servers, a bunch of databases. So this allows us to scale out the so-called horizontal scaling. And I assume Matt will be talking about that next month, as opposed to vertical scaling. It also allows us to scale down if we need to. If there's times of the year or times of the day where we don't need as much scale, we can scale down. So we have some flexibility there. And we also have flexibility in terms of schema. So one of the side effects, I guess you could say, of a distributed database is that each piece of data has to be independent because it can live on any one of those nodes in the cluster. And so we can use JSON to give it some of a semi-structured piece of data. But none of these data are beholden to each other. They're not stored in a table that has a schema enforced on it. None of them are relations. So we can have a piece of data that's a user that has a name field, and a piece of data that's a user that has a first name and last name field. Now, I'm not saying that's a good idea. This specifically is a good idea, but it gives you some flexibility in how you want to store the data. This is useful for lots of use cases where you're pulling in data from different sources, like an IoT, or you have a flexible pieces of data like a catalog or user profiles, session store, things like that. Very, very useful for that. And then availability, or sometimes known as high availability. This is the idea where you have a distributed database. And if one of those servers goes offline or goes down or crashes, that's okay. The rest of those servers can pick up the slack. And this is a picture back when we used to able to go to movie theaters. And I took a picture of this and I said to my wife, I'm going to show this picture in every one of my slide decks because you're demonstrating a high availability perfectly right now. You don't even know it. So if you go to AMC theaters, they have these big arrays of all these Coke Freestyle machines. If one of them has to go down for maintenance or to get refilled or whatever, there's other machines there that customers can still get their soda before they go to a movie. And they don't have to wait until 2 a.m. 2 a.m. on a Saturday, for instance, to service those machines. They can service them during business hours. And so they can do this without affecting the customer's, the availability of the soda to the customer. Performance is another reason, latency and concurrency. NoSQL systems are designed for specific access patterns. And so there's lots of performance measurements out there, lots of benchmarks and things that we can talk about this. This can be very subjective, of course, and there's lots of different reasons, different things to say, like what do you mean by performance? What do you mean by concurrency? What do you mean by latency? You know, what kind of load? How many reads? How many writes? Things like that. We're not going to talk about that too much today, but that's another reason why people go to NoSQL. Use cases for NoSQL. You know, in the early days of NoSQL, the use cases were either relatively slim, or it was kind of we have to do this out of necessity. Because we're giving up things like ACID transactions, we're giving up things like the SQL query language in order to achieve high scalability, high availability, things like that. So things like caching and session, user profile, catalog, these were perfect use cases. But as NoSQL has matured, it's added ACID transactions. It has SQL as a query language. It has all these other features that we're going to talk about today that allow it to be useful for a lot of other use cases. So even in the financial sector, insurance, social media, of course, loyalty programs for hotels, all kinds of things, is a really great use case for that. And so that's just a partial list of use cases for Couchbase customers. It doesn't even include customers for other competing NoSQL databases. So you can go check out that list if you like there. And I'll just say as a capper on the why is this quote here. And no one knows who said this quote originally, but different isn't always better, right? NoSQL isn't inherently better than a SQL approach, But better is always different. So if you're struggling with SQL, you're struggling with relational, then it might be the case that a NoSQL database could help you. All right. So I'm going to try to monitor questions the best I can, but we might also just save those for the end as well. So I'll just sort of take a pause every once in a while, look at the chat. But if there's questions that I don't get to, feel free to ask them again towards the end if we have time, or I'll give you my contact information and happy to talk with you about it afterwards. So I want to talk about JSON data modeling. So now we're digging into document databases specifically. And so think of it as a key value database fundamentally, but we're focusing on JSON data being stored in those databases. So let's start with a simple whiteboard exercise. We're going to build an application that's we're going to have to model our customer in that application. This might be one of many models, but let's just look at customer to begin with. This is an example of what a customer might look like. So there's lots of things in here. That might be part of a proof of concept. We haven't even picked a database yet. We're just sort of mapping out this customer on a whiteboard or whatever. So there's things in here like a rich structure. There's attributes for this user. So name is an attribute, or maybe even a sub-attribute like first name, last name. There's relationships. So this customer is connected to other customers through some sort of connection, whether it's a family shared account or it's some sort of social media or something like that. There's a value evolution. So as we add more purchases, we keep adding more purchases as Helen continues to make those purchases to the model. And there's a structure evolution as well. So we may start out with the credit card number being an attribute of Helen Mallory, the customer. That's maybe not a good design though. So we want to evolve that structure so that we can accept multiple credit card numbers, multiple payment methods to that user. So we need to be able to change our structure sometimes, some sort of structure evolution. And if you're like me, and I know I am, even though I've worked at Couchbase for nearly 5 years, I still just kind of a relational model pops into my head. This was drilled into me in college and in my first several jobs. So this is kind of what comes into my head. It's like, okay, we're going to model a customer. We have a customer table, we have a context table, etc. We've got foreign keys, and I can do all these things: rich structure, the relationships, the value evolution with multiple rows. The structure evolution is where relational gets a little trickier, because if I want to remodel my data to add a billing table, this involves having to create a new table, create a foreign key, move the data from customer over to billing, all those sorts of things that I have to do to change that. And that's just a really simple schema change. When schemas get more complex, schema changes can get more complex. I may have to take the system down for some period of time or put it in read-only mode or something like that while I make that schema change. So I want to start here though, and I want to do a side-by-side comparison between relational model, how it might look, and a JSON model, how it might look. So we're going to start here with one table and one row, and on the left side, and one document on the right side. And so this is a pretty straightforward mapping here. If I just want to take the name and put it into a name field in JSON, it's a pretty straightforward thing. It's a flat JSON data and flat piece of data in relational. Not a big deal. One key difference here is that relational has a primary key, which in this case is just one column with one field there. In the document database, documents have a document key that is kind of like a primary key. It has to be unique to whatever collection or bucket that document is in. But essentially, it's the same kind of concept. So we'll make our document key the same as our primary key. Now let's get a little more complicated. We introduce a second table, a second row of data. And there's now a foreign key. So the purchases, each row of the purchases maps back to the customer via foreign key, which is CBL 2015. And so if we want to turn that into an object, a C# object, Java object, for instance, now it involves a join or an ORM like Hibernate or Entity Framework or something like that. So we have to put those pieces together. I kind of think of like putting a document through a paper shredder, and you store those shreds in individual documents, whereas the individual rows. Whereas the document model on the right, it's all still in one piece. So what I've done is I've gone ahead and put a purchases array into the JSON document, and so it's now just a single piece. But I'm able to do this because JSON has an array type. I can have an array of objects, for instance. over there on the right side. All right. Okay, so far so good. This isn't too bad. We're nesting instead of splitting data up, and we can just add another row to the customer table. So now we have 3 pieces of data in 2 tables. We still have 1 piece of data. Gosh, microphone stands really giving me problems today. We have now an array with 2 items there on the right. The quotes are optional for the keys. In JSON, no, that's not true. The quotes are not optional. We don't get into it, but the quotes are not optional for valid JSON, let's say. In JavaScript, if you're defining an object, they might be optional, but for JSON notation, they're not optional. Yeah, maybe it's my hands. Yeah, I just keep swinging my hands around, banging into the mic. All right. Now connections. So we're going to have a customer related to another customer. So one way we might do this in relationals, we have a mapping table that has a compound foreign key, customer ID and connection ID, and maybe some information about that connection. So it's my brother, it's my father. We all share the same Hulu account, for instance. So we map them together with this row. Definitely a Stan from Monkey Island situation. That's a deep cut, but I like it because I'm definitely like him. The way we do this in a document database is we can't really nest this because we have an n+1 problem. We're going to be nesting a customer within a customer. That leads to nesting customer within a customer within a customer, and so on. That's just not going to work. So we can do a similar thing where we can refer to another document in our document. So I still have a connections array, but inside that array, I have basically it's going to refer to another document with a document key. And I can store that relation information right here. Say it's a relation as father. Okay. Now notice I don't have both of them. I don't have both of the keys there. I just have the key to the other document, SKR007. I don't need to store the CBL 2015 here because it's domestic data now. I don't need to have that compound foreign key. All right, so let's put it all together here. And this is kind of maybe a kitchen sink model of how this might work. So we have the full relational model on the left there. We've got 4 tables and 2, 4, 6, 7 rows of data, all shredded into a relational database that corresponds to a single document in the document database on the right, because we have all the nested data there, and some referring to other customers which are not pictured, but they're there. All right, and just to drive home the point about structural difference is that notice in my customer table and the document, I've modeled it so that the card number is a property of the customer. Now that is a naive design, let's say. Just from experience, I know that's probably not the best way to model this, but let's say I start modeling it that way. All right. If I want to go and remodel that into a relational model, I have to introduce another table and move the data over. I mentioned all this stuff before. Introduce a foreign key, introduce a new table, migrate data over, remove those columns from customer, all that kind of work, which doesn't seem like a big deal, right? But if we're talking, millions of records, for instance, that could be a very long operation, and meanwhile the database may not be available during that time. So we're back to our 2 a.m. on a Saturday data migration sort of thing. Now, over in the document database, I've also modeled this to be a billing array. Instead of having those card numbers be top level, they're now inside a billing array. But one very subtle thing here that you might not have noticed is as I swapped to the slide here, this one was CBL 2015, this one's CBL 2016. Both those documents can live in the database side by side. There is nothing that Couchbase is going to do, Couchbase or any NoSQL document database is going to do to enforce any sort of schema upon those documents. Now, you may not want it to stay that way, or maybe you do want it to stay that way. Maybe it's okay to have 2 different models of the same document in the database there. That's something that I think a lot of people who are coming from a relational world, a relational background, might balk at initially and say, "Ooh, this is tricky. This could be an issue for me." There's a couple approaches you might want to take to dealing with that. So you might want to add version numbers to your document. And I put a very simple, just integer here. It could be more complex than that, right? But we say, okay, the document with just the name field is version 1. And version 2 is the document with the first name and last name split out. And then upon retrieving that document from the database, we can then branch on version 1 or version number, determine how we want to proceed. And that can be more than a number. It could be a .NET type or assembly or however complicated you want to make it. But this is an approach you can also kind of take in a relational database. You just have to have a version table, for instance. A lot of migration tools will do that sort of thing. But you can't really take this exact same approach because in a document database, both of these can exist. In a relational, they can't both exist. You'd have to have a name, first name, and last name column. And so you have to have some nulls and things like that in there. Another approach you can take is the sort of big bang reversioning. We can just say, run a big update statement, basically. Say, take all our documents that are named, split them up. They're now all first name and last name. Now, that's kind of the big bang approach or a series of batch queries. And that might be okay. You could take that approach with relational as well. That's kind of the approach you have to take with relational. That can get complicated, though. And the third approach is we can do a cooperative reversioning. So it's kind of a mixture of the two. We start with a document that just has the name field. We retrieve that in a web application. When we go and save it, we save it as the new version with first name and last name. This is kind of something that you do a lot. It doesn't happen very often, but when say a hashing system is broken, for instance, let's say you're storing your passwords as MD5. This is kind of the approach you have to take to update to SHA 256, for instance, because you don't know the password. You have to let the user log in, give you the password, and then save it with the new hashing format. Yeah. So if the key is missing in a GET query, how do you know if the item is missing versus the key is not there? Will it return a different indicator? Yes, very good question. And that is one that I will definitely answer. It's going to depend on the database, but I will definitely answer that later on when we talk about data access. So just wrapping up here, there are some tools that help you through this process. Just like there's tools for the relational world, there's tools for the non-relational world. So here's a few examples I can think of. Hackalade is a relatively new startup that does a lot of NoSQL database modeling. So Couchbase, of course, but Mongo, Elastic, Cassandra, Dynamo, Firebase, Firestore, all those sorts of things are supported by Hackalade. Irwin and Idera are kind of, they've been around for a while as modeling tools, but they have added support for Mongo and or Couchbase to those tools. And if you don't want to buy those licenses, you can go with something simpler like JSON-editor-online.org. It's a no-frills, simple offering, but it can still help you with modeling and diffing and things like that. Really helpful tool there. Okay. All right, so I want to get on to accessing data because we can talk about what's the best way to model data, but ultimately it matters when you're actually trying to retrieve or store that data. The modeling decisions should take that in consideration. One of the things that's a main difference between NoSQL and SQL is that with SQL, you basically have just the one way to access data through a SQL query or to write data through a SQL query. With NoSQL, you're going to have multiple options to access data. And some of those, ironically, could include SQL, as you're going to see later on here. But it could also be the key value lookup, or text search, analytics, MapReduce, all kinds of ways to access data. So you have multiple options, and so you have to think about those multiple options. So just a quick run through here, a key value lookup. And this is a C# example. This is not a C# presentation, but hopefully this is legible to anyone who's familiar with JavaScript or Java as well. But basically what it is if I want to get something from the database, I can look it up by the ID or by the key. And I can save that. I can store that in C# as a shopping cart object, for instance, or whatever object I want to cast it as. I'm getting JSON, but I'm putting it into, I'm serializing it into a C# object shopping cart. And the other way around is if I want to create a shopping cart, I can just insert some object with some key into the database. Whatever that object stored as in C# or Java, it will get serialized to JSON and stored as JSON in the database. So in either of these situations, I didn't have to write a select or an insert. I'm just using the KeyValue API directly. And the KeyValue API is always going to be the fastest way to access data in NoSQL database. It's always going to be the very, very fastest. There's very, very little overhead. It's just a direct lookup. And so KeyValue is the way to go if you're looking for just raw performance. Some recommendations for modeling when it comes to key values is make your keys natural keys if you can, right? A surrogate key would be like a GUID or an integer, but if you can use a natural key like a user ID or a case number or something like that, that's going to be a good choice. Human readable keys. Again, a surrogate key like a GUID or integer is fine, but a human readable key is going to help you see at a glance what's in this data. And deterministic, we'll talk about what that means in a second, but if you follow all these things, you're going to make sure that your keys are semantic and have meaning, and it's not just a big bunch of GUIDs that are just out there and don't really, to a human don't mean anything. What do I mean by deterministic is we can, if we're going to try to use the KeyValue API as much as possible, we can kind of march through a graph of our data in a deterministic way. So let's say I have a blog site, for instance, and I log in, I type in my username, Matt, I type in my password, I can go to the author, Matt document, see if the credentials match. If they do, okay, log them in. Now that I know that it's Matt, I can now look up all Matt's blogs by going to the author, Matt blogs document and get a list of all the slugs, for instance. And if I have a list of all the slugs, I can go to an individual blog post, like blog C#9 features. I can look at the content of that blog and edit that. And if there's comments, there may be a second document storing comments that I would want to ignore, for instance. Are there any downsides using natural keys? A good question. I would say the downside there is that if you're using some sort of meaningful data as a natural key, that it's going to be difficult for you to change that key going forward. So you might have seen this in some systems, for instance, that make you jump through hoops to change your username. I'm guessing that's because they're using your username as a natural key behind the scenes. So going through that process is something they don't want to do very much. So for instance, if you're going on to Twitch, for instance, some of you are on Twitch right now, changing your username is a whole deal sometimes, or at least it used to be. I don't know if it is anymore. So if you use a surrogate key instead, you don't have to worry about that. So something's not going to change or don't want to change very often, like a case number, for instance, would be a natural key. Okay, so based on that, just on the key value as the API we're focusing on it, and this is something I want to focus on first because this is something that all document databases should have a key value API. And so these sort of rules apply to all of them. The next step from here is to drill into some specifics that not all databases support. But here's some rules of thumb, some strategies for modeling if you're going to focus on the key value API. And if it's a one-to-one or one-to-many, nest that data if you can. So in this case, the purchases there are all nested inside the document. That makes sense to do that. If it's a many-to-one or a many-to-many, we're going to store them as separate documents. We're going to refer because Jane Smith mapping to another customer, it's not just Jane Smith or mapping to that customer, mapping other people to that customer, things like that. And if you're going to be doing reads, if your reads are mostly the parent fields, right? So just the name and date of birth here and whatever attributes of the customer. If we're doing mostly reads of the parent, store the children as separate objects. So we don't have to bring in all the children's value in that one get. We can make it a very slim get. And of course, you see where this is going. If your reads are mostly parent and child, so if it's like a shopping cart or a purchase history, then store them as nested objects. So you can get them all in one operation. Some more rules of thumb. So if your writes are mostly parent or child, not both, store them as separate documents. Again, just so we can minimize the traffic and minimize the documents that we're reading and writing. And if the reads are mostly, the writes are mostly parent and child together, store them as nested. So again, if we're updating a purchase history or a shopping cart, we're probably going to be reading and writing them both together very often. So here's the summary of that. This might be the place you want to take a screenshot, for instance. Usually pause here for a second. People get their cell phones out when we're doing it in person. Some questions in there about Cassandra. Yeah, so Cassandra's not a document database, so I won't touch on that very much. But that is a NoSQL database. It's called a wide table or a wide column database. Yeah, I don't want to get into that too much because I know we're limited on time as it is. But I have lots of thoughts about modeling in Cassandra as well. Another thing to think about, and this is something I bring up, even though I don't think all document databases have this, but many of them do, is what's called SubDocument Access. And this will figure into your modeling as well. And this may allow you to break some of those rules I just mentioned. Is if I just want to update a part of the document, let's say I have a huge, like 2 megabyte document, but I only want to update one Boolean in that document. With a plain KeyValue API, I have to bring the whole 2 megabyte document over the wire and then update the one Boolean and send the whole thing back over the wire. Well, what I can do instead is something called a SubDocument API, where I can update just part of that document. I can say, okay, just give me the address, and I'll update just part of the address. I don't need to send the rest of it over the wire. So this is a very, very helpful tool for if you have large documents, for instance, or you're doing a lot of reads and writes, a lot of contention on a document, but different parts of the document, so you can cut down on that contention. Okay, so that is kind of the overview of basic modeling, the modeling basics for JSON data with a KeyValue API. Now, as I said, NoSQL is not just about the KeyValue API. There's lots of other APIs that we can access the same data with, just different methods. So I want to use Couchbase as an example because I work for marketing at Couchbase, of course. But a lot of these same things apply to other NoSQL databases. So the key value is always going to be the fastest because you can see there it's going directly to the data. There's nothing to stop in between. There's no additional steps. You know the key. Here's the key. Give me the value. Done. The second access you might want to look at today is a query. Now for Couchbase, this is known as Nosql, N1QL, which is a type of SQL dialect. That doesn't go directly to the documents. As you can see there, it has to go through an index or indexes. And it has to also parse the query out as well. So there's multiple steps there. So it's not going to be as fast as the key value lookup, but it's going to be potentially more flexible. We don't always know the key ahead of time. Another one is full text search, where I'm just going to cover this briefly, but maybe we want to search by a text string, and it's going to be a more advanced text search, like a Google search, basically, where we're searching for keywords or variations on those keywords. We want to rank them in a certain way. So again, it goes through, has to parse the full text query, has to go through full text indexes, and so on. And there's other ones I'm not going to cover today, like a MapReduce, which is kind of on its way out in the NoSQL world, except for some very narrow use cases. And analytics, which is all about like big data and BI and stuff like that. And I'm not going to cover that here today, but for Couchbase, that's also done with SQL. So here is the Couchbase language. It's called Nosql. So with SQL Server, you've got Transact SQL, T-SQL. With Oracle, you've got, what is it, PL SQL, they call it. With Couchbase, you've got Nosql, is the SQL query language there. So if you've seen SQL before, you know how to write Nosql in Couchbase. This is a few examples of it right here. So for instance, if I wanted to get all the card holders who have a Visa or a MasterCard, that's very, very hard to do with a key value lookup. I'd have to create additional documents, create my own indexes basically that contain Visa card holders, MasterCard holders, things like that. But with this, I can just query on the JSON properties themselves. I can say, give me where card type equals Visa or card type equals MasterCard. As you can see, I can do joins, all that kind of stuff here with Couchbase as a full SQL implementation. It's the full thing. Everything you'd expect from SQL is there in Couchbase Nosql. Query plan is very important. So I mentioned having to go through indexes. That's true of relational databases, and it's true of non-relational as well. So here's a simple query to find all the airlines that have a name that contains US in the name, like US Air or US Airlines or whatever. And so if I ran this query through a query analyzer in Couchbase, it would show me a visualization. Here's all the different steps in the query. This is a relatively simple one, so it's just a straight line, but they can, of course, get just very out of control. If you're familiar with execution plans, you've seen some crazy ones. But you can also see that the yellow one takes the most amount of time, right? It's 98% of the query is fetching the data. And so what we can also do is it can also get some suggested indexes. If we run the query, SQL Server, Couchbase, all kinds of tools will suggest a better index for you. Also suggest a covering index, for instance, where we can skip the fetch step completely because all the data we need is in the index already. So no need to fetch. We can skip that step, make it even faster. But of course, the T dot star up there is the problem with that. We don't want to cover every single field in the document, so we should change that T dot star to just the fields that we need. There's a question about metadata in there. So that's a little bit of a weird syntax thing with a Nosql. So I mentioned that each document has a key, right? Document key has or also known as ID. In Couchbase, that's part of the metadata. And there I'm saying meta .id. So give me the key. I'm going to join on the key of the document. There's other things in the metadata, but that's mainly the one you're going to be looking at with Couchbase. That's just a little syntax thing for Couchbase. It's just basically think of that as like the primary key of the document. Okay, so we talked about this. Full text search is another way to access data in a NoSQL database. So this revolves around text. Well, actually, that's not 100% true. It's called full text search, but really what it is mainly it's for text search, right? So if I wanted to do a search for the word submarine, I could go through all the landmarks, for instance, in the database, and it could tell me this is the one that we think is most relevant to the word submarine, and because it mentions submarine the most times or something like that. And it can also find variations. It can match on submarines plural. It can match on maybe sub-marine, something like that, or maybe a slight misspelling of submarine. Kind of like you'd expect from a Google search engine. But the thing with full text search is that it indexes a different way than the standard index for SQL query. So the SQL query index back here, this is actually using what's called a B tree. This is not super important, but if you're a algorithm nerd, maybe it is important. It uses a B tree algorithm to do the querying in the indexes. Full text search uses what's called a what is it called? I'll just skip ahead to find out. A inverted index. Sorry, that's what it is. Inverted index, which is great for things like stemming and language awareness, but it's also really good for things like a geospatial lookup. If I want to look up things by geography, I want to find locations that are within a specific polygon, for instance, or a radius. And it's also good for queries that have a lot of disjuncts, for instance. If you are writing a SQL query and you have where X or Y or Z or foo or bar, if you have a ton of those ors in there, it might be better to use a full text search index to pull that off. So full text search is kind of a misnomer a little bit, but I mean, that's kind of the main use case. That's why it's called that. So anyway, this is the breakdown of those different methods. So key value is always going to be the fastest. If you have a good key strategy and an optimized data model, this is going to serve you well. You don't always know the key in advance. So a full text search is going to help you if you're looking for geography or language awareness or some special cases of lots of disjuncts. And then everything else can be done by a Nosql query. So you can query it however it's modeled, as long as you have good indexes. It's going to go through a B tree for that. And also note with Couchbase and maybe some others, but with Couchbase, you can combine a Nosql query and a full text search. So you can use the B tree for part of it, and you can use inverted index for part of it, and it can work out great together. Maybe that's database nerd stuff, but that's kind of the breakdown there. Just make sure you pick the right concept to access the data and model your data accordingly. If a certain model is going to provide the possibility of more key value lookups, go with that because it's going to be faster. And then everything else, like a Pareto rule, everything else can be done with Nosql queries. Okay, let me see if there's any more questions here before we go on to the next session. Upsert, yes, upsert is another operation that you can do in Couchbase, either in Nosql or with the KeyValue API. Upsert is a combination update insert, basically. Who doesn't want to be a database nerd? These days, it's more about the front end, the fancy React JavaScript stuff. But my interest is more in the back end database server side stuff. That's where my interests are. All right, migrating data. All right, we're doing okay on time here, I think. Now, I say migrating here. I don't want to give you the impression that I want you to go out and ditch your relational database and switch to NoSQL right now. I don't want to give you that impression. I ultimately do want you to do that because I work for a NoSQL company. But you got to make sure you have the right use case, and you got to think about your approach. Why am I migrating to NoSQL? So it might not be about switching from one to the other. It might be about synchronizing data from one to the other for different use cases, for microservices, for instance. Or it might be about not necessarily migrating my data on this project, but migrating my thought process because the next project might be a better fit for NoSQL. So I want to talk about this scale here. It's kind of an arbitrary scale that we've come up with. There's different levels of migration we could think about. And the top level, number one, is the total rewrite. We're not going to migrate. We're just going to rewrite the whole application and do the whole thing over. And this is an area that I think a lot of NoSQL companies and databases have kind of focused on, especially when that modeling exercise that I showed you is, you want to get everything nested, and you got to figure out what's the right thing to nest, what's the right thing to refer. And so if you do that from the ground up, you're going to get the most benefit from a NoSQL database. It's also going to be the highest effort and the most risk to take that approach, that full rewrite approach. And so the other way, and this I think goes into Jacob's question here, is about denormalizing documents or throw them into one big nested document, is all the way down there at level 5, is just hosted. So we're going to do like a lift and shift of your relational data, just store it as it is in a NoSQL database, in all the 1,000 pieces, all the different shreds that it's in. This is as few as changes as possible. Just take it out of relational and put it into NoSQL. And then everything in between is kind of where you can work your way up to. So you can start at 5 and maybe move up to 4 to optimize your data to provide better performance and generally speaking, better performance, but a more efficient model perhaps. Right, so that's kind of the scale there. And so the just hosted is going to be the lowest effort and lowest risk, I think. But it's also going to give you the lowest benefits, at least immediately. You're not going to necessarily see a performance boost right away if you're just going to lift and shift that relational data over. But it gives you a place to start. And so this is something that I'm kind of focused on this year, is helping people try to just do that really basic conversion as just an easy way to get started. You don't have to go into the whole deep modeling exercise if you don't want to. Maybe you start out doing this just as a proof of concept to see, is this NoSQL right for my project, or is this going to be more trouble than it's worth, sort of thing. And then we can move up, optimize later if we need to. There's some tools to help you do the migration. So some of these you may already have licenses to, or you may have heard of already. These things are tools you can use to move data over, do a straight lift and shift, or build in some logic about your modeling. I keep saying lift and shift. That's a term that the people use to move from a local data center to the cloud, but we're kind of doing a similar thing here with relational to NoSQL. One of these tools I want to point out here, because I think it's so great, is Apache NiFi. It's a tool that probably very few of you have ever heard of. It is an incredible tool for managing and building data flows within the enterprise. The visual tool can connect to just about any database, any data source, any API you can think of. It's really, really cool. It's something I discovered when I started working with the Reds, and I just want to flog it every chance I get. So Apache NiFi, a very cool, interesting tool for moving data around, maybe for migration, maybe for synchronization. Other tools you might not have heard of, but are also useful for this, is Dart. Debezium makes some great connectors for Kafka. Yeah, some cool stuff here. But NiFi, definitely cool. You can also do like a build your own type of thing, where you can kind of take what pieces you have and moving them around. So like a Python is great for this, or like a shell script like Bash or PowerShell. Just combine a bunch of curl statements and things like that together. Usually NoSQL databases ship with command line tools to help you with this. So things like CB import for Couchbase or Mongo import for Mongo. It's just tools that allow you to import either CSV or JSON data, that sort of thing. SQL Server comes with integration services, SSIS. So you can connect that and build some data, export some data. Golden Gate is the equivalent of that for Oracle. If you've got wheelbarrows full of money for that, you can use that kind of tool. Okay, but basically what I want to do is I want to think about that level 5 and just keep things as simple as possible here. So this is kind of like a really bare bones level 5 approach. We can just go to our relational database, export it to some CSV files, for instance, and then use those command line utilities to import into our database, and just kind of a raw form of data right there in place. And once that in place, we can start then building our application to connect to this raw NoSQL data, or maybe we can just start thinking about transforming that data in some way to a future state, a optimized state. So kind of the cloud dialog, we have the lift and shift, but we also, after the lift and shift, we can start breaking it down into taking advantage of specific cloud services that might save us money or perform better, things like that. All right, so maybe it's just one entity at a time. We can start with a user profile or start with a shopping cart, and just see if we can nest that into an aggregate and see how that improves our performance. And so then we can go from there. We can start moving towards levels 4 and maybe up to 3 and 2, for instance. We can think of that first bucket as like a staging bucket as we move data in and we transform it into the final optimized state. So I've got some blog posts that kind of show a proof of concept of this. If you want to take the really, keep it simple, stupid, KISS approach to it, you can do that. But ultimately with the optimization, you have to align your data with the ways you want to access it. So think about the key value. If my data is shredded into a bunch of pieces, it's going to take 5 or 6 maybe key value lookups. So we can start nesting that to turn it into one key value lookup instead. Or we could turn it into a query with joins to start with, and maybe we want to reduce those joins because joins are expensive. But just the key here is that if we start at that lowest basic level, you have to also align your expectations, is that we're not modeling our data to take advantage of NoSQL capabilities. So if you don't see those benefits right away, don't be scared off, because we're just kind of starting out simple as we can. Okay, I have a demo I want to show you, but let's take a second here, look at any questions. Wingman131 says, is that like an ETL tool? I'm not sure which one you're talking about. I mentioned several tools back there like SSIS that could be used to build an ETL, things like Informatica. All those kinds of tools can be used for ETL. Yes, ETL is extract, transform, load. That's kind of a data migration process or tool, absolutely. Let's see. If a company wants to build this is from Danielle McDankenstein. Do you think NoSQL would be a good choice for CRM? Sure, I think so. Yeah, CRM makes sense. In fact, one of the things I mentioned early on as a use case was called Customer 360, which is kind of like a CRM, except that it's not necessarily sales focused. It could be like use cases that Couchbase have done for Customer 360 is you have a big enterprise, let's say like Comcast, for instance, and you call into Comcast and you're mad about something, right? That's the only reason you call into your cable provider. And you have a question about your service or something's gone wrong. Well, Comcast has like 1 billion different systems, 1 billion databases all throughout their enterprise. Not 1 billion, but they have a lot. And so what you can do with a NoSQL system is you can actually set up those ETLs to do it either on a nightly basis or even better on an immediate basis, like with a Kafka streaming, for instance, to ingest all those pieces of data about a customer into one place. And so when that customer calls up and says, hey, I have a question about my service, well, now I have a single pane of glass, a single system. It gives me a 360-degree view of that customer from all those different sources. So yeah, I think that might be a good place to start. What are the main benefits of Couchbase over Mongo? That's from Elmos. Definitely have an answer for you if we get past the demo. That's a question I get all the time, so we'll get to that one for sure. Any good sources from AJ Bot? Any good sources for example models for common use cases, like a storefront model, for example? Yeah, so I know Couchbase certainly ships with several sample data sets. So if you're familiar with SQL servers like AdventureWorks or Worldwide Imports, for instance, Couchbase ships with things like a brewery, like a beer sample or a travel sample, which travel. That used to be something I do all the time. But ships with sample data sets, and there's sample applications that go with it, things like that. Yes, absolutely. Is a document database the same as a KeyValue database? This is from 1T_. Yeah, I kind of covered this at the beginning. You can think of a document database as like a special case of KeyValue, or the other way around. KeyValue is a special case of document. The idea is that document databases, each document has a key, yes, so it can still be used as a key value store. But the important part of this is that the data is stored in a specific format like JSON that allows you to perform other things like index individual fields, run queries against secondary fields, not just the key. So there's some gray area there. There's very few just pure key value stores anymore. Most of them have some sort of document database capability, with a few exceptions maybe. Okay, I think it's time for a little demo here. And this demo is in C# and .NET. I'm a .NET C# guy. You don't have to, I'm not going to go into the code very much here today. But if you are a C# .NET type of guy, I would definitely, or type of gal, I should say, I definitely want you to take a look at this project because I would love some feedback. I love your thoughts on it. But what I've done is I've created here a program, a little utility, a library called SQL Server to Couchbase. And the idea here is to automate as much as possible the migration of a SQL Server data model and data into a Couchbase data model and data. And this is at that level 1, or sorry, level 5, where it's just a lift and shift. And it's going to be automated as much as possible. We can't automate everything. At least I can't automate everything, at least not yet. I'm working on it. But this is kind of what I'm thinking about in terms of my approach. So here I've got on the screen here, I've got SQL Server. This is all running on my local machine. And speaking of AdventureWorks, I've got that loaded into the database right here. AdventureWorks is a fairly well-known sample data set from Microsoft. I've tried it on the other ones as well. So there's a few other sample data sets like Worldwide Importers, Stack Overflow, New York City Taxi, etc. Northwind even, if you want to go back that far. But AdventureWorks, I think, is a good one because it has a lot of stuff going on. It's like a kitchen sink of SQL Server functionality. A lot of data types, schemas, indexes, lots of interesting stuff in there that I'd want to maybe convert over. Northwind, I looked at Northwind and it just kind of looks kind of scrawny compared to AdventureWorks. So it's just not as interesting as a demo, but that would work for that too. I have tested on Northwind. Anyway, so here's AdventureWorks in SQL Server. I've also got, if I can find the tab here, I've got Couchbase Server running here on my local machine, just a single node. So I don't have the big fancy multi-node cluster. This is just a cluster with one node, but it's fine for demo purposes. So I went to service here, you'd see it's just one server, right? In production, you typically see at least 3 servers here, if not a whole bunch more. For instance, LinkedIn uses a lot of Couchbase, tons and tons of Couchbase. And so they have huge clusters and they have lots of clusters over at LinkedIn of Couchbase. Anyway, I digress. So I've got in Couchbase this concept of bucket. So someone asked about sample data sets. Here's the travel sample data set already loaded into Couchbase. So if you wanted to check that out. But let's just create a new bucket here. I'm going to create just a brand new from scratch, AdventureWorks. I'm going to call it AdventureWorks 2016, and I'll give it 512 megabytes of RAM. We can talk about that later if you want to. Regular old Couchbase bucket, and there we go. So brand new bucket in Couchbase. A bucket is kind of analogous to like a catalog in SQL Server. So AdventureWorks 2016 here, AdventureWorks 2016 there. 0 items in it, and just to show you, nothing up my sleeve here. Oh, there's something up my sleeve. Let me delete these users here first. Sorry, don't want to be seen as cheating. No users in the database. And indexes, there are some indexes, but they're all for the travel sample. There's no indexes for the AdventureWorks bucket there. So we're starting literally at scratch here. All right. Now, let's go ahead and run this program here, and fingers crossed that it works. This is using my SQL Server to Couchbase library, and I've got a sample console app that's going to examine, circumspect, if you will, the AdventureWorks database and build as best it can a conversion of it in Couchbase, in a NoSQL database. So it's gone through and it's creating some what are called scopes and collections. It's creating users, it's creating indexes, and now it's moving some data over. Now, what I've done for the sake of this demo is AdventureWorks is 500,000 records, rows of data, and hundreds of indexes. I don't want you to have to sit here and watch as those all get copied over. So I'm just sampling them. So I'm saying, give me the first 5 indexes and give me the first 100 rows of data from each table. So it's not going to be the whole data set. Just want to preface that going in. It shouldn't make much difference, but for demo purposes, I want to preface that going in. Okay, let's close this down here. All right, so now in AdventureWorks, over in Couchbase, I've got 4,000 some items in there. So if I click on this, you can see some information about the bucket. But if I click on scopes and collections here, so this is in SQL Server, you've got this idea of schema. So notice this table here has a schema called human resources, has a table called departments. So the equivalent in Couchbase would be a scope over here called human resources. And inside that, I've got these collections. So a bucket contains scopes, a scope contains collections. Okay, with me so far? And then inside of, let's go look at a person and address. Inside of that collection, there are documents. And so over here in person address, I'll select some rows from there. And so you can see all the rows in, well, first 1,000 anyway, from the person address table. And over here on Couchbase, you can see the first 10, I guess, documents that correspond to those rows. So look here, I've got the primary key of 1, I've got a document key of 1. I'll just look at this individual documents. And you see it's converted it to JSON data. So address is now a string in JSON. We've got some null values in there, some GUIDs, some dates, things like that. That's all converting this row of data over as best it can to JSON format. So that's just a really basic lift and shift of data. Now, in AdventureWorks, there are certainly some things that we could move around. So like for sales, for instance, we've got sales order header and sales order detail. And I think that there is a foreign key relationship here. We might want to consider combining those into one document. But for now, in our NoSQL database, they're still split up into their own collections there. So sales order header, sales order detail. So I'd still have to execute a join on them. The other thing I want to point out is indexes. So over here in AdventureWorks, we've also created some indexes in Couchbase. So these are just kind of literal translations of the indexes in SQL Server. Right? So this is an index on 2 different fields. And so that index is there on the same kind of data. Security. So one thing about AdventureWorks, maybe someone can correct me on this, but there's not, well, that's not it. There's not much in the way of users defined for AdventureWorks. So I had to invent one. I created this person microservice because you might want to limit a user to a certain scope, for instance, or a certain set of tables. So I created one that has access to just 3 tables and has insert, update, select for all of these except business entity, also has delete permission. And so over here in security, I have a corresponding user that has a similar set of really, really fine-grained permissions in Couchbase. Now, the key difference here is that, like I keep mentioning, with SQL, you just have the one way to interact with data, SQL. In Couchbase, you have multiple ways. You can execute a query, you can do a key value lookup, so there's different permissions for those different operations. So there's more permissions in here because I'm trying to be as permissive as possible. But this is certainly something that you don't want to necessarily rely on automation. You want to make sure your security is correct. You don't want to, this is just a good place to get started, but you want to do a manual review of this to make sure the right accounts have the right access. Okay, and the last thing I want to do, which I think is pretty cool. Oh, and I kind of spoiled it there. Spoiler alert. This is going to work, so it's not that big of a spoiler. But let's say I have a SQL query over here on AdventureWorks, and I pulled this from Microsoft documentation. This is a query that gets, I think, employees and the city that they live in. So execute this on SQL Server, and it gives me those results. Now, here's the really cool thing. And I told you that Couchbase's Nosql language, Couchbase's SQL, is a full SQL query language. So I can take nearly the identical query, execute over here on Couchbase. The one difference being string concatenation is it's not a plus, it's 2 bars, which I think is the Oracle style. Otherwise, this is identical query to SQL Server. Now, it's not going to run because I didn't move over all the indexes, and Couchbase will not allow what the equivalent of a table scan by default, because that could result in some nasty timeouts. So if I were to move all the indexes over, which would take probably 20 minutes for me to do that, this query would run and give me the results. The same exact results as over here, except they'd be in JSON format instead of in a result set. So that's a pretty cool thing I like about Couchbase, is because I've used SQL my whole career, and I can still use SQL in a NoSQL database and get all the same benefits of scaling and performance and flexibility, but I still have SQL as a query language. Okay, so that is it for the demo. If you're interested in that, I'll give you a link to the GitHub repo. It's totally open source. I'd love to hear suggestions for features, feedback on it. Can it do this? Does it do this? How does it do this? I welcome that kind of stuff. I'd love it. I want to go on to a summary here, and then I'll get to any questions we have left, because we are running a little over time now, so I apologize for that. But just, they say you only remember like 3 or 4 things from any given presentation. So here's the things I want you to remember, is pick the right application. Focus on something where NoSQL can actually help you, can actually benefit you. Don't just move it over to NoSQL because it's the new cool thing you want on your resume. Make sure it's as a right application for it. So scaling, flexibility, certain performance requirements. If you have a microservice architecture, SOA architecture, those are great for this because you can peel off just one part of your whole system and try it out in NoSQL database. Do a proof of concept. So whether it's a lift and shift like I showed you, or if you want to do your own ETL process, import, export CSVs, that's fine. But when you do that, you can think about your modeling. You can think about what you're going to focus on. What are your success criteria? How do I know this is going to benefit me? So think about that during proof of concept. And you can use a tool like those I mentioned for modeling to kind of prove those out, to say, oh, this is going to work for us. Is our team going to like this? That sort of thing. Make sure you're using the right data access methods. With SQL Server, you just have the one, just SQL queries. But with NoSQL, a key lookup's always going to be super fast. So if you're using a SQL query to look up one row of data, for instance, change that to a key value lookup. You're going to get a huge performance boost just right there. But don't be afraid to fall back to the text search or the SQL query when you need to. Here are some links for you. I wish I could copy and paste these right into the chat. I don't think I have the right window open for that, but you can take a screenshot of this if you want to. That first post there just got published yesterday, and it shows a lot of the stuff I'm talking about in today's presentation about that tool that I'm working on. So if you're interested in an automated, or at least semi-automated way to move to a NoSQL database, definitely check that one out. The other two I've written a while ago, but I think they're still relevant. One is about making a proof of concept to move from relational, and one of them is about a lot of the JSON modeling concept we talked about with the embedding or the referring, sort of aggregating or not approach to modeling there. This is my family when we were on a cruise ship. Back in those days, we'd go on a cruise ship. My enormous head barely fits in a picture there. But you can find me on Twitter. I'm always happy to talk about anything I've brought up here, any sort of database stuff, server-side, backend stuff. That's my jam. If you have technical questions about Couchbase, the forums there, I'm always hanging out in the forums as well on there. So if you have .NET questions, I'm definitely monitoring those. But more general questions, there is a huge forum, huge community for Couchbase for you to check out. What I'd like you to do next is, for one, I'd want you to download Couchbase. Couchbase 7 is currently in a beta right now. A lot of the stuff I showed you with collections and scopes is there. You can also try out the Nickel query language. ACID transactions are all available in Couchbase 7. So that's a cool thing that we didn't talk about very much, but NoSQL has always been kind of but it doesn't have ACID. These days, that's no longer the case. Couchbase and competitors like Mongo and Cosmos have added ACID transactions. If you want to check out the Couchbase community, you want to learn about people who are using Couchbase for their use cases, ask questions like the one about, hey, is NoSQL the right fit for a CRM? This is the place to go. Check out the Couchbase Influitive site. That's a special invitation code. They'll give me $5 for every person who signs up. No, I'm just kidding. They don't give me anything for that. But that's a join code you can use to get into that community. And the last one is a GitHub link to the tool that I demoed, SQL Server to Couchbase. It's a very much a early stage of that tool. But if you have feedback or have questions, I would love for you to post an issue there or to try out the code and see what you think. All right, so that's the whole presentation. I can get some more questions from the chat here. Thank you, AJ Bot, for posting those links. I appreciate that. Thank you very much. Let's see some more questions. I know someone asked about Couchbase and Mongo. I can go into that if you want to. That's maybe a bit of a longer discussion. I want to see if we can find some other interesting, more data modeling questions. Are there any gotchas when using Couchbase? This is from Wolf EJW86. Any gotchas when using Couchbase in a serverless environment, such as connection handling, etc.? Yeah, I mean, this is true with any database actually in a serverless environment. Is that a serverless environment like Azure Functions, for instance, will try to reuse any of your resources, but you have to prepare for it to go away at any time. So there's some things to think about in terms of concurrency and thread safety when it comes to connecting. And this is, again, not just for Couchbase, but for any sort of database connection from a serverless environment. Yeah, definitely want to think about that. I think I've got a blog post on that, actually, that exact thing, and certainly a podcast about it as well. That's something I ran into a while back. So really good question there. Let's see, what else? I see it sorting the ID by, this is from AJ Bot. I see it sorting the ID by string, 1, 10, 100. Is there a way to specify that ID as an int so it sorts correctly? That was just kind of the default view that Couchbase was giving. Certainly you can sort it by however you'd want to sort it. If you want to sort it by number, yeah, absolutely, you can do that. But I think just by default, it's just the best performant way is to sort it by string and just pull those to that view. Yeah. Jacob Pirate is Pirate. Cool. Do you still need to define a schema for performance hints or let it figure it out for you? You don't need to define a schema for performance hints, but you do need to define an index. And sometimes you'll need to give your query some index hints to use the right index. And to let it figure it out for you, again, with the indexes, again, with Couchbase and other NoSQL databases, you can put in a query, and you have to have an index, but it might recommend, say, hey, this index might be faster. You want to go about it this way. Here's our recommended index for improved performance. Yeah. Let's see, what else? There's a question about auto increment sequence numbers from Jacob Pirate. So certainly you can do auto incrementing numbers in document databases. It's a little different sometimes. You have to, because it's distributed, right? There's no relation that documents belong to. You might have to create what's called a counter document that just kind of keeps track of the latest number. But that's a common use case. Yep. Okay. I mean, if there's any more questions here, happy to, like I was telling ahead of time, I'm happy to go as long as you guys have questions, but I don't want to keep you all night. So
what I think might make sense, Matthew, if it's okay with you.
Sure.
So we have a Zoom meeting after this, and if anybody's interested, we might want to do the questions there. That could be an excellent place for not just submitting questions, but actually a back and forth, which could be fun.
Absolutely.
How do you feel about that?
I'm willing to spend a little bit of time there. Sure.
Awesome. Okay, so anything else that you want to say before we finish up, Matthew? Anything you want to call out? Or?
No, like I said, this is just the only things that, if you're interested in this, these are things I'd ask you to do. Explore these
Awesome.
things and reach out to me if you have questions or comments or any sort of thing you want to talk about in regards to databases. I'm all ears.
Cool. Don't go just yet, everybody. So we're first of all, Matthew, thank you so much. This was an incredible talk. Can we get some applause in the chat for Matthew, please? That just so much appreciation for doing this tonight, Matthew. And obviously follow Matt on social media. I think he posted some of those. Is there any specific ones you want to call out or anything, Matthew?
I don't think I put a LinkedIn link up there, but I'm using that a lot more these days. So you can find me on LinkedIn as well.
Excellent. That sounds good. Cool. As promised, we're going to go ahead and give away that JetBrains license. I'm going to go ahead and drop you out here, Matthew, and we will catch you in the Zoom afterwards. So go ahead and if you want to enter, just type #CSC in the chat, and that will automatically enter you into the drawing. While you are doing that, and we're waiting for people to do that, make sure you go ahead and RSVP for next month's talk and add it to your calendar. You definitely don't want to miss this one with Matt Eland. You can RSVP either on Meetup or on LinkedIn. We're happy with either one. Randy just dropped that link in the chat as well if you want to click on that. So we'll give it just another minute here to allow everyone to enter. Yes, so our presentation are always 6 p.m. Eastern time. Okay, so it looks like I saw one CSC. It's got to be #CSC. All right. Give it about 10 more seconds, and then Kat will draw our winner for tonight. Don't forget to RSVP and follow us on LinkedIn and Twitter, of course. All right. Oh, we still got them coming in. All right. Go ahead, Kat, when you get a chance, and draw our winner. All right. Tatiana G, you are the winner tonight. Congratulations. And thank you to JetBrains for giving us that license to give away. I do want to say thank you to our attendees. We love you. We do this all for the attendees because we know how much value it adds. So we really appreciate you. We'd be delighted to hear any feedback you have for us. We want you to let us know what you enjoyed. Let us know what we could have done better. Of course, any complaints can be addressed directly to me. This is the guy responsible if there's something you don't like. With that, I hope that you'll join us on Zoom for the post-presentation social time. We'll drop that link in the comments if you need it. Randy, would you drop that there? And so without further ado, I bid you all a good evening, and I look forward to seeing you on the Zoom chat. Thank you so much.